is. So yesterday we discussed writing polar form, then few simplifications, and remember it, whenever we get a complex number with a denominator, if it is two terms, we multiply by the conjugate, like in rationalization, multiply by the conjugate to make denominator a real number. And we did till December 11. Now question number 12. See, question number 12, easy one. Starting question number 12. Two complex numbers are given. Z1. Two complex numbers are. Now he came in. Two complex numbers are given. Z1 is 2 minus I and Z2. Z2 is minus 2 plus I. Sulaiman Ahmad, you are waiting there in the waiting room for more than 3-4 minutes. I told you earlier also before starting class, if you are waiting for more than 10-20 seconds, that means something is wrong with your name and roll number. Several times I asked you, but you are very ignorant about it. Now, when you roll the roll number first and name, within 10 seconds is minus 2 plus I. The question is to find the real of Z1, Z2 by Z1 bar. The real of Z1, Z2 by Z1 bar. And second part is to find imaginary of 1 by Z1. We need to find these two. Real of. It's nothing, it's very easy. We need to find the real part of this complex number. So what to do is first we will find this complex number. And to find real and imaginary part, we know we have to write that in standard form. Standard form means the real part first, then plus I in the imaginary part. So the parts with I and parts without I. The parts without I, that is called the real part. For example, if x plus iy is given, the real part is x, imaginary part is the part coming along with I. That is, or we can treat it as coefficient of I. So here, so we will find this, to find this complex number, we will find numerator and denominator separately, then go for simplification. So Z1, Z2. See, the numerator is Z1 into Z2. Z1 means 2 minus I, Z2 is minus 2 plus I. Normal multiplication, like opening bracket, in algebraic expressions, we know how to open the bracket. Exactly same thing. Opening bracket, take 2, multiply with each and every element here. Then take minus I, multiply with each and every element here. So taking 2 and multiplying 2 into minus 2 is minus 4. 2 into I is plus 2I. Now minus I into minus 2 plus 2I minus I into I is minus I squared. Again, further simplification, minus 4 plus 2I plus 2I becomes 4I. I square is minus 1. So minus I square will be plus 1. Reason I square is minus 1. Again, can be further simplified. Minus 3 plus 1. That is minus 3 plus 4I. This is the numerator. That is the numerator. Now, coming to denominator. Denominator is Z1 bar. See, what's on Z1? Our given Z1 is 2 minus I. Then Z1 bar denotes the conjugate of that complex number. What do you mean by conjugate? Conjugate means Two numbers, two complex numbers which differ in the sign of their imaginary part. So here imaginary part is minus sign. So plus sign. Okay. So it's 2 plus sign. Now our expression is Z1, Z2, minus 1. Z1, Z2 we found it is minus 3 plus 4i divided by Z1 bar is 2 plus I. Again, whenever I comes in denominator, whenever I comes in denominator, we will multiply by the conjugate. So multiplying by the conjugate, we get Z1, Z2 by Z1 bar is equal to minus 3 plus 4i by 2 plus I multiplied with the conjugate of 2 plus I. The conjugate of denominator, conjugate of 2 plus I is 2 minus I. See that always, whenever we get a complex number, if it has a denominator, especially with two tails, if the denominator is a complex number in the form a plus ib, always multiply with the conjugate to write this in the standard form. Now again, this one. Numerator directly opening minus 3 multiplied with these two terms. Minus 3 into 2 is minus 6. Minus 3 into minus I is plus 3i. 4 into 2 plus 8i. 4 into this is minus 4 I squared. I is I squared. The whole point is someone got the answer. What about denominator? So say if your answer is correct. And 2 minus I. A plus B, A minus B, it is A squared minus B squared. Again, numerator minus 6, 3i plus 8i is plus 11i. I squared, we know I squared is minus 1. So minus 4 I squared is minus 1. Minus 4 into minus 1 is plus 4. 4 minus plus 1. Again simplifying, minus 6 plus 4 is minus 2 plus 11i by 5. Therefore, we got Z1, Z2 by Z1 bar. Now we have to separate it. Separating into real part and imaginary part. So real part is minus 2 by 5 plus 11 by 5i. This I, whether you are writing last or the beginning, doesn't make a difference. You can write I in 11 by 5 or 11 by 5 into I, doesn't make a difference. Now, this is this complex number. Now, what's our question? Our question is to write the real part of this one. The real part of this complex number. We know that a complex number written in standard form, so its real part is minus 2 by 5. The same question, if it is asked to find the imaginary part, I have like this one, imaginary of this one, then your answer will be 11 by 5. See that? It is not 11 by 5i, it is 11 by 5. It is 11 by 5. So first one. Now, second one, imaginary of C. Z1 is 2 minus I, Z1 bar is 2 plus I. Then what we need to find Z1 bar. I hope you have completed this one. Now to find Z1 bar. So Z1 into Z1 bar is 2 minus I, 2 plus I, which is 2 square minus I square, 4 plus 1, that is 5. Now Z1 bar, this 5, we have to write as a complex number. That's in standard form. How to write 5 as a complex number? So the real part is 5. All real numbers can be considered as complex number. 5 plus 0 and with imaginary number 0. Imaginary part of 0. Now the question is to find the imaginary part of, okay. No, this one is not this one. We need 1 by Z bar is 5. Then we need 1 by Z bar. This will be 1 by 5. This can be written as 1 by 5 plus 0. Anyway, what will maybe the imaginary part of this will be 0 because there is no, it's a real number. See, this one. We found Z1 bar. Yesterday, I gave a note. Do you remember it? Z bar. Z bar means a complex number multiplied by its conjugate. Remember in that way. Remember it? Any complex number multiplied by its conjugate will give square of its modulus. Square of its modulus. Yesterday we learned square of modulus. So Z bar is modulus Z square. That's a property. We can treat it as a property. So here Z1 bar will be modulus Z1 square. So modulus of Z1 square. And see that modulus of Z1 is modulus of 2 minus I. How will you find modulus of 2 minus I? Modulus of A plus IB is root of A square plus B square. So 2 minus I will be root of 2 square 4 plus minus 1 square. Minus 1 square is 1. 4 plus 1 5. Root 5. So root 5. Then Z1 square will be 5. Same thing here. So Z1 bar, instead of multiplying it directly, you can write modulus Z1 square also. That way also we get. Question number 13, I think I gave it as a homework yesterday to find the modulus and argument. You have to do it. Question number 14. From this 14, 16, 17. 14, 16, 17, these 3 questions, one of these questions will be always asked in examination. 14, 16 and 17. So these 3 questions are important. 14, 16 and 17. 14th one, it's an interesting one. Question number 14. The question is, find x and y if x minus iy multiplied with 3 plus 5i is the conjugate of this complex number is the conjugate of minus 6 minus 24i. The question is to find x and y if this complex number is the conjugate of this one. So we will name this as z. Let z is minus 6 minus 24i. Now in the question, what they are mentioning, this is the conjugate of this one. So we will find the conjugate of this z. So conjugate of this z bar. While writing the conjugate of this complex number, the expected common mistake. At least some of you will write the conjugate as 6 plus 24i. See that 6 plus 24i is not the conjugate of minus 6 minus 24i. Conjugate means the number which differ only in the sign of imaginary part. Only the sign of imaginary part. So this is wrong. So the sign difference is only for the imaginary part. So this real part minus 6 divides 6. That is it. Now, so this is the conjugate of this one. Now what is given? This is the conjugate. So we keep it as equation number 1. Now we will find this x minus iy its standard form. X minus iy 3 plus 5. We have to simplify. Simplify, take x, multiply each and every time. X into 3 is 3x. X into 5y is plus I into 5x. Minus iy into 3 is minus I into 3y. Minus 5y I square minus I square 5y is I square 5y. Again simplify. Further simplifying 3x plus I can be taken common 5x minus 3y. I square is minus 1, so it is plus 5y. Because I square is minus 1. Now writing the real parts together, 3x plus 5y plus I into 5x minus 3y. This is the simplified standard form of this given complex number, x minus iy into 3 plus 5y. So, now what is given in the question? The question says that this is the conjugate of this. So, the conjugate of this one is equation number 1. So, given what is given, 1 is equal to 2. Isn't it? This given complex number is simplified and wrote in standard form. It's already known this is the conjugate of this. So conjugate is this one. So these two are equal. That means this minus 6 plus 24i is equal to 3x plus 5y plus I into 5x minus 3y. That's me. These two are equal is given. Again, see the question. What we need to find. What is the question? The question is to find x and y. How to get x and y? If these two complex numbers are equal, whenever two complex numbers are equal, we can write the real parts are equal. So what is the real part here? Real part here is 3x plus 5y is equal to, what is the real part here? Minus 6. Equation number 3. Equating real and imaginary parts, the 3x plus 5y is equal to minus 6. Similarly, the imaginary part, 5x minus 3y is 24. We got two equations in x and y. Linear equations in two variables. Last year we learned it. Linear equations in two variables. If we get these two equations in two variables, you know how to solve it. Elimination method is a better choice. Elimination, how to eliminate this one? We multiply first term with second coefficient Second one with first coefficient to make yes. So this equation number 3. Equation number 3 we can multiply by 3. Equation number 3 multiplied by 3. Equation number 3 multiplied by 3 means multiply everything with 3. So 3 is 9x minus 5 is 15y minus 6 into 3 is minus 18. Then equation number 4 multiplied with the first coefficient 5 will give 5 is 25x minus 5 is 15y, 24 5 is 120. Now what to do? Add it. Add it, then 25 plus 9 is 34. This cancels is equal to 100. Find x. Then substitute that value of x in one of the easy equation. Easy equation is this one. This is the other equation, bigger equation. Substitute the value of x in equation number 3, we get 5. Completed. Completed. In the meantime, take the attendance also. You substitute it in one of the easy equations to get the value of 5. Easy equation is equation number 3. So x is equal to 102 by 34, which is 3. Substituting in 3. Substituting in 3. 3 into 3 plus 5y is minus 6. 9 plus 5y is minus 6. 5y is minus 6 minus 9. Y is minus 15 by 5, which is minus 3. Therefore, x is equal to 3, y is equal to minus 5. So this is a good question. See that, understand the wordings. This is the conjugate of this one that is given. So we found the conjugate of this one, we put equation number 1. Then the given complex number, we wrote that in standard form, equation number 2. According to question, this complex number is equal to conjugate of this. So we equated the conjugate of this one. Then after equating, we got 2 equations in x and y. Solve it, we get the value of x and y. This question is a seen question. At most, they can change this number. The idea is same. So you will get another 2 equations which can be solved. I hope you got it. Now, question number 15. Question number 15. Is find the modulus of 1 plus I by 1 minus I, 1 plus I by 1 minus I minus 1 minus I by 1 plus I. See, always, whenever the question is to find modulus or argument or inverse, what it may be, first thing is writing that in standard form. So we need to simplify. And whenever a complex number, if in denominator we have an expression with I with 2 terms, always we go for multiplying by the conjugate. So one method, take each of those terms, simplify each term and add it up. But in this question, we have a convenience. So remember it, in any question, actually, if you are multiplied by this conjugate, we can find this value of this one. Here also we can find. But here you can see these denominators are conjugate of one another. They are the conjugates. So instead of simplifying each one, directly take the LCM. If you are taking the LCM, then denominator will be a real number, right? So simplifying it means directly take the LCM. See that we take the LCM only if they are conjugates. If they are not conjugates, for simplifying such term, take each term separately and simplify. This one, if they are conjugates, take the LCM 1 minus I, 1 plus I. Numerator. See, numerator 2 by 3 plus 3 by 2. LCM is 3 into 2. What is numerator? Numerator is 2 into 2 square plus 3. This you learn in class 4 or 5. Is it? Whenever LCM is product of denominators, directly multiply it. That is easy. So here, exactly same. 1 plus I into 1 plus I is 1 plus I the whole square minus 1 minus I the whole square. Numerator. Here use the identity A plus B the whole square. Here use A minus B the whole square. Use it A plus B the whole square. 1 square. 1 square is 1 plus 2 into 1 into I is 2I plus I square. Minus. After minus, do remember to put bracket. Yes, Khaja, you got the answer. 1 minus I the whole square. Again, A minus B the whole square. 1 minus 2AB is 2I plus I square. The whole by denominator is 1 minus I square. This is 1 plus 2I plus I square minus 1 plus 2I minus I square. Divided by 1 plus 1 because I square is minus 1. Here 1 and minus 1 can even I square minus I square cancel. I square is minus 1, so instead of directly we can cancel. What is left? 2I plus 2I is 4I by 2, which is 2I. It is 2I. So our answer is 2I means 2I plus 0. Then the question is to find modulus of it. Modulus of A plus, this is 0 plus 2I, right? 0 plus 2I. So modulus root of 0 square plus 2 square. Root 4, 2 is here. Modulus of a complex number A plus IB is root of A square plus B square. I hope you have completed. Again, the next one is also a good question. Question number 16. That's also a frequently seen question. Question number 16. This question number 14, 16, and 17. Next question. These three questions, remember it, 14, 16, and 17. From these three questions, one of the questions is always seen in this examination. So question number 16. Question number 16 is x plus iy the whole cube is equal to u plus I. x plus iy the whole cube is u plus iv. The question is to show that u by x plus v by y is 4 into x squared minus y squared. U by x plus v by y is equal to 4 into x squared minus y squared. Again, these are easy questions. X plus iy is u plus x. So this u plus iv will start from the given thing. U plus iv is x plus iy the whole cube. That is u plus iv. X plus iy the whole cube. A plus b the whole cube. Expand using the identity a plus b the whole cube. We know the expansion of a plus b the whole cube is a cube plus 3a square b plus 3ab square plus b cube. A cube plus 3a square plus 3ab square plus b cube. So using that identity here, instead of a cube, it is x cube plus 3a square x square. B is I by 3a square b plus 3a b square square of I y. Square of I is I square y square plus cube of I y, that is I cube y cube. I cube y cube. Again, we will simplify it further. X cube 3x square y and writing I at last. Now, we know the value of I square. Similarly, we know what is I cube. Powers of I square is -1. I cube means I square into I, which is -I. I raised to 4 is I square into I square, which is 1. So remember that cycle goes. So this I as it is. Now I square is -1. So this expression becomes -3x y square because I square became -1. I cube is -I. So this becomes minus I into y cube. So we got u plus iv as this one. This complex number, write in standard form. Writing in standard form means first real part, then imaginary part. What is real part here? The real part is the part without I. So x cube. Then this one is having I. This one minus 3xy square. This is the real part. Plus the part with I, that is called the imaginary part. So how many parts are there with I? This one. 3. So taking that I common, 3x square y minus y cube. This is imaginary part. So we got this complex number. This is the standard form. So now equating real and imaginary parts. See, or directly indirect parts. If two complex numbers are equal, then their real parts and imaginary parts are respectively equal. That means real part of this one, u will be equal to x cube minus 3xy square. And the imaginary part, b. Imaginary part means part with I. We don't write IV, The imaginary number is b. B is what is here? 3x square y minus 5 cube. This is the real and imaginary part. Now, what is our question? After finding x and y, our question LHS. Our LHS is u by x plus b by y. We found the value of u and v already. So u is x cubed minus 3xy squared by x plus b, or b is 3x squared y minus y cubed by y. U by x, b by y. Can we further simplify? Check the numerator. From first term, the numerator, x can be taken common. So if we take one common x, from this x cube, x is taken, remaining x squared minus 3. This x is already taken, y squared by x. Similarly here, if we take y, 3 x squared, y is taken, minus y cube, 1 y is taken, left with y squared, by 1. What happens? X cancel, y cancel, left out x cube minus 3y squared plus 3x squared minus y squared. Again, x cube plus 3x cube is 4x cube minus 3y squared minus y cube is, no, this is x squared. X squared, 4x squared minus 3y squared minus y squared is minus 4y squared, which is 4 into x squared minus y squared, that is answer. Taking 4 common. So this question also, Abdul Mateen, you asked me a question. What is the application of complex numbers? Lot of applications. See, actually complex number means imaginary number. In our number system also, we learn whenever we get a situation where we need to find square root of a negative number. Square root of a negative number is a complex number. So in some cases, we need to find square root of a negative number. So this is question number 16. Now, I hope you have completed. Now question number 17. This is also a frequently asked question. This question number 17 can be done in many ways. Whichever way is easy for you, go for it. See question number 17. Our question is, if alpha and beta are different complex numbers with modulus of beta, it is given modulus of beta is 1. The question is to find modulus of beta minus alpha by 1 minus alpha of. The question is to find beta minus alpha by. This can be done in many ways. One of the ways I will show you. If you find any other method, lot of methods are there. By taking alpha and betas, a plus ib and c plus id, that is lengthy. or taking this as z, then z bar, then z bar we can find, multiplying another fraction like this. Now, I feel the easiest way. See, yesterday we learned z bar. Z bar is modulus x square. So here, beta is a complex number multiplied by its conjugate. A complex number multiplied by its conjugate will give square of its modulus. We wrote that as a note yesterday. Z bar is modulus z square. So beta bar is modulus beta square. But modulus beta is already given in the question. In this particular question, modulus beta is 1. So it's equal to 1 square, it is 1. So in this question, beta bar is 1. So what I'm doing, this numerator, beta minus alpha y, this 1 I'm writing it as beta bar minus alpha bar beta. This is the reason. Because beta bar is 1. So instead of 1, I replace it with beta bar. This is, now, we know that z1 by z2. This is same as modulus of z1, is it? So for a fraction, so we are separating modulus of beta bar minus alpha. Model here, I am taking beta common. Beta bar minus alpha. Because fraction. This one. Beta minus alpha. Again, product of two complex numbers. This is modulus of beta bar minus alpha. Here the reason is beta z1 into z2 will be modulus z1. Because see, product, taking the product, modulus of product or quotient of product, we can separate it. Now, this is modulus of beta minus alpha by modulus of beta. This is beta minus alpha the whole part. Again, reason is z1. This is z1 bar minus z2 bar. We can separate it. Okay, it's nothing, just splitting out, always breaking. First, this quotient we made different, then this product we made different, then this bar also we combined it. Now, this is modulus of beta minus alpha by modulus of beta. Modulus of beta minus alpha by reason modulus of z bar is same as modulus of z. Why? Modulus of a complex number and its conjugate. Modulus of a complex number and conjugate. For example, see if a complex number is 1 plus I, its conjugate is 1 minus I. If you are taking the modulus of this one, this is 1 square plus 1 square, root 2. This will be 1 square plus minus 1 the whole square. That's also root 2. So remember, modulus of a complex number and modulus of its conjugate for the same. Now we can cancel these two. What is left out? Right, what is left out? Left out is 1 by modulus beta. Just cancel. And modulus is equal to 1 by modulus beta is, that is given. Given if modulus beta is 1, 1 by 1 is 1. So 1 is the answer. Again, so these three questions. Question number 14, 16, and 17. From these three questions, one question is seen in all examinations. One of these questions will be always asked. I hope you have completed. One more question, then we will stop. Question number 18. These properties, these are those properties in the side itself as reason. Come to question number 18. Question number 18. Find the number of non-zero integral solutions. Modulus of 1 minus I, the whole raised to x, is equal to 2 raised to x. That means we have to find solutions. After finding solutions, the question is to write the number of non-zero integral solutions. That means non-zero value. You have to check how many non-zero values are possible. Okay. Here. Solving the equation means finding the value of x. How to start? Modulus of 1 minus I. What is modulus of 1 minus I? This is the root of 1 square plus minus 1 square. A plus IB. Modulus of A plus IB is root of A square plus B square. We use it several times. Remember it. Modulus of A plus IB is root of A square plus B square. So modulus of 1 minus I is root of 1 square plus minus 1 the whole square. This is equal to 2 raised to x. This is root 2 is equal to 2 raised. Okay. The x is there. The whole raised to x. Root 2 raised to x. See, our x is in the exponent. Equation. We could have equated the exponents if the base root of first step once again. I'm sorry. Modulus of A plus IB. How will you find modulus of a complex number? Modulus of a complex number by definition. Modulus of a complex number by definition is root of A square plus B square. That is what we wrote in the beginning, definition. So modulus of 1 minus I is root of 1 square plus minus 1 the whole square. That is the definition of this one. Raised to x is here. Now these exponents, we could have equated exponents if bases are equal. So how to make this bases equal? Can we make this root 2 as 2 raised to something? This root 2 means 2 raised to 1 by 2. The whole raised to x is 2 raised to x. This is 2 raised to x by 2 is equal to x. This implies if 2 raised to x by 2 is 2 raised to x, this means x by 2 is equal to x. X is equal to 2x, or 2x minus x is 0. X is equal to 0. So solution is x is equal to 0. Now what's our question? What is our question? Our question is to write the number of solutions. So how many solutions are here for this question? The number of solutions is only one solution, 0. But the question is to find the number of nodes here. One solution is there. Solution is 0. But the question is to find the number of non-zero solutions. So how many non-zero solutions are there? 0. No solutions. No. Therefore, there are no non-zero solutions. There are no non-zero solutions. This is better. If you are writing 0 of the answer, then you may think actually 0 is a solution. The question is to find number of non-zero solutions. So number of non-zero solution is 0, means no solution. There are no non-zero solutions at all. Start today's class. Any doubts? Any doubt? What's the meaning of integral solution means solutions are integers. Integral values means 1, 2, 3, 4, 5. Integers. They are the integral values. Integral values means without decimal. Integers. That is integral solution. Anything else? Integral solution means without fractions. From yes. Anything else regarding today's class? Any doubt? Okay. So see you tomorrow. 0 can be no 0. Okay. 0 can be an integral solution, but it is given. The question is given to find non-zero integral solutions. 0 definitely 0 is an integral solution, but our question is to find non-zero integral solution. That's why we wrote no non-zero solutions. Yes. Anything else? Is no integral doesn't mean they're consecutive. No. Integral solutions means which are not decimals or fractions, which are integers. That's meaning. Anything else? Nothing. So we will see you next class.